Bismillahirrahmanirrahim. Today we are going to start first session of our lecture week number 8. This lecture is based on our course learning outcome number 4, that is explain operating system support for processes, threads, scheduling, synchronization, deadlock, virtual memory and file system. Today we will start our discussion on deadlocks in operating system. We know that in operating system the two very important things are process and resources. And we also know that the number of resources are less as compared to the number of processes. So in multi-programming system, several processes they compete for a finite number of resources, because the number of resources in our computer they are limited. So what are these resources? Our processor, memory, keyboard, mouse, monitor. So all these are resources and we have limited number of resources and we need to give them resources in some proper order that the deadlock did not occur. Now, when the deadlock will occur, a process requests a resource, a process has requested the resource, and if the resource is not available at that time, the process enter in waiting state. So if process have requested a resource and if that resource is not available, so what operating system will do? He will put that process in waiting state. And sometimes this is the case, a waiting process is never able to change state. He is not able to change state because the resource it has requested are held other waiting process. Okay, maybe the resource that the process he has requested, maybe it is held by another waiting process and he is not releasing that resource, okay, until he get his request. So this type of situation is called deadlock. Okay, so if the deadlock occur, then we have ways to solve the deadlock. But what are the reasons when the deadlock occur, we will discuss in this session. Okay, that here I have some example. That what is normal mode of operation? That normal mode is if any process need any resource, so he has to. There are 3 steps. This is the normal mode of operation, that he will request for the resource. This is first thing. Now the system will check the request, what he has requested, it is available or not. If this is available, then it will assign that resource to the requested process. Okay, then after that he will use the resource. If the resource is available and it is assigned to that process, now next step is he will use that resource, and when his work will finish, he will release the resource. Okay, let's suppose in use there is one example. If, for example, if the resource is printer, the process can print on the printer. So this is printer is one resource. So if I given some command to print, so it means the process he needs a printer. If printer is busy, already is printing some another request, so then he has to wait. But after waiting, when the printer will assign to him, then he will use that printer, that resource, and then the third step is after his work will finish, the process release the resource. Okay, so these are the 3 steps: request, use and release. Now there is one example from our life. We are also facing this situation, that situation, deadlock situation. For example, the bridge crossing example. If you see this diagram, there is a bridge here. Here we have a bridge, but This bridge is also a resource to cross the river. Maybe this is the river. Okay. Now if you see here that on the bridge only one car can cross at a time. So this is your bridge and only one car can cross at a time. Now if you see the situation, this is car 1 and suppose this is car 2. Now they are in front of each other. This situation is the deadlock situation. Car 1 is not able to move towards right side and car 2 is not able to move towards left side. Now both are stuck. Okay, this situation is deadlock situation. So maybe many times we have faced this problem on the road whenever we are driving. Now why this occur? Because traffic is only in one direction. This is our first thing. Only one direction we have traffic, not is one way, like this. Now each section of bridge can be viewed as a resource. This is one resource. Now if deadlock occur, it can be resolved if one car back up. Now what is the solution? That solution is car 1 he go back and give the way to car 2, or car 2 go back and give the way to car 1 to cross the bridge. In this way, several cars may have to back up if deadlock occur. If this situation occur, then maybe, because if you see here after 2 there is another 2 cars, after 1 there are 2, maybe they also have to go back. Okay, so if deadlock occur, then of course we have some solution to solve that problem, to solve that deadlock. So this is one example that from our daily life. So we have some more examples. For example, two trains traveling towards each other on the same track. If they are coming on the same track and traveling towards each other, so there will be situation in future that deadlock will occur. They will be in front of each other, like here the two cars are in front of each other. Another example is a person going down a ladder while another person is climbing up the ladder. Okay, so one is going down, another is going up. Then there will be a situation occur that is called deadlock. Okay, now how to solve this? Either the person who is coming down he go back to up, or the person who is going up to come down. Number 4, that is related to you, that you cannot get a job without experience. You cannot get experience without job. Okay, if you are fresh graduate, so you need job to get experience. Okay, clear? So you need job to get experience. But if the requirement is you cannot get a job without experience, so how you will get? This situation is also a deadlock situation for students. Okay, so these are some examples. You have many other examples that where we are facing this problem. This is deadlock situation. Okay, now we will move to our actual topic, that in operating system what are the reasons the deadlock can occur. So we have some necessary conditions for deadlock. Now a deadlock can arise if the following 4 conditions hold simultaneously in the system. Now we have to check that our system have these 4 conditions or not. So what is the first condition? That is mutual exclusion. Okay, hold and wait, no preemption, and circular wait. So these are the 4 main conditions, main reasons of the deadlock. Now whenever we are going to check that our system may go into deadlock, so we will check these 4 conditions: mutual exclusion, hold and wait, no preemption, and circular wait. Okay, now what is mutual exclusion? That, as its name shows, mutual, between process. Exclusion. There is a fight. And why this is fight? Because at least one resource must be held in non-shareable mode. Non-shareable. If our resources in our system are not shareable, then the situation of deadlock can occur. So non-shareable means that only one process at a time can use the resource. We have only one instance of that resource and only one process can use the resource. If I give you example of whiteboard. This is a whiteboard and only one person can use whiteboard at a time. I am using this whiteboard, and if you want to use this whiteboard, then I have to release the resource. This whiteboard is one resource. I have to release the resource because this resource is not shareable. Only one person can use this. Same thing here. The only if resource is non-shareable mean only one process can use that resource. Then if another process requests that resource, if the requesting process must be delayed until the resource has been released. Now waiting time, it will be how much? It depends. And if the wait is not finished, waiting time is not finished, so situation is deadlock. And why this situation occur? Because the resource was non-shareable. Like whiteboard, this is non-shareable. If I refuse to release this resource, then how you will use this? But another example, if I give you that shareable resource like the light in this room. Everybody is getting light. There is one light and we are sharing the light. Okay, so everybody is getting the light. That is shareable. But whiteboard, non-shareable. The marker, whiteboard marker that I am using, this is also non-shareable. Only one person can use at a time. So this is first reason that a deadlock can occur in system if there is a mutual exclusion. At least, what is the reason? That this is very important when you will check the system there is a deadlock or not. You have to check the first one, mutual exclusion. At least one resource must be held in non-shareable mode. Okay, one resource must be in non-shareable mode. Now what is second condition for deadlock? That is hold and wait. Now its name shows clearly hold, to hold some resources and waiting for some other resources. This is another condition for deadlock. Okay, a process must be holding at least one resource and waiting to acquire additional resource. And these resources may be currently held by other processes. Now, here on whiteboard, let's suppose I am using red pen, okay, red marker. I need another color, suppose blue color or black color. So I am holding which resource? That is red color, waiting for black color. So if I say that I will not release this resource until get the black color, so this is called hold and wait. Ideal situation is whatever I am holding, I must release that and then I request for other. Okay, so this is the situation, that request, use and release. If I say I will not release the red color marker, red color resource until I get the black color resource, black color marker. It means this is situation of hold and wait. I am holding one resource and waiting for another resource. If this situation is in our operating system, that process holding resource and waiting for other resource, then this can lead towards deadlock. Okay, so this is second necessary condition for deadlock, hold and wait. So first one, mutual exclusion, and this occur because we have non-shareable resource and second necessary condition, that is hold and wait, that we are holding one resource and waiting for other additional resources. Okay. Now, number 3. Now, no preemption. No preemption means that we are not able to take resources back by force. Resources cannot be preempted. A resource can be released only voluntarily by process holding it after that process has completed its task. Until process did not have completed his task, we are not able to take the resource back. This is called no preemption. Preemptive approach means that by force we can take control back. In scheduling algorithm, you have seen that after when the time slice expire, okay, or we have some different algorithm, first come first serve, priority scheduling, round robin, or priority or shortest job first. So according to that algorithm, we are executing the process. Okay, so in first come first serve, if you have seen that process that comes first will use that processor, that is one resource, first until he complete his work. Other process they have to wait. But if a process it is very long, so it will take more time. So it means other processes they have to wait. Okay, so this is number third reason that no preemption, that we are not able to take control back. Okay, we are not able to take any resource back from any process. If we want that our system must run smoothly, then we need to include the preemptive approach. If you remember that in multitasking we have two ways, preemptive and cooperative. If we have preemptive approach, that if the time slice is expired, then interrupt the system and take the resource back and give to the other process who is waiting for that resource. Okay, so this is number third necessary condition for deadlock. Number 4 is circular wait. As its name shows, there is also wait, but circular wait. The process they are waiting in circle. Let's suppose here I have set of process P0, P1, P2, P3 up to so on Pn minus 1 and at the end Pn of waiting process. They all are waiting such that P0 is waiting for resource which is held by P1. Okay, P0 is waiting for resource which is held by P1. P1 is waiting for resource which is held by P2. P2 is waiting for resource which is held by P3, and so on. Pn minus 1 is waiting for resource which is held by Pn, and Pn is waiting for resource which is held by P0. Okay, see here that we have a circle. Here from this, if you see this one, there is circle, and this is called circular wait. Now P0 is waiting for resource which is held by P1, P1 is waiting for resource which is held by 2, and so on, and P0 will not his resource that currently he has until he get his requested resource which is held by P1. P1 will not release the resource that he has currently until he get the resource which is held by P2, and so on. So it is making the circular wait. All the process they are waiting, they are holding some process and they are waiting for another. This is also an important condition for deadlock. Okay, so we have 4 main conditions that are very important to check that deadlock will occur or not. So these 4 conditions: mutual exclusion, hold and wait, no preemption, and circular wait. Now Next, how we can describe that deadlock occur or not. So there is one thing that is called resource allocation graph. Resource. We need to make a resource allocation graph. Which resource is allocated to which process? Okay. So deadlock can be described in terms of directed graph called system resource allocation graph. Okay. So we will make one graph. That graph will be directed. That we must have to show the direction. Okay. So graph, you know that it consists of set of vertices and set of edges. Sometimes we also say set of nodes or vertices. In graph we say set of vertices. Now the set of vertices are partitioned into two different type of nodes. So we have process, we have resource. Okay. So process and resource. So how we can check the deadlock occur or not? We will make a resource allocation graph, and this resource allocation graph will consist of set of vertices and set of edges. Okay, so we have vertices, process and number of resources. Whenever we have set of process and set of resources, then we have always two type of edge. They are connecting different vertices. First edge is request edge. A process is requesting for resource. So whenever a process is requesting for resource, this will be the directed edge from process to resource. Okay, so maybe we have one instance of that resource, or maybe we have more than one instance of that resource. Here we use pi to resource type rj. Okay, so directed edge, if you have edge, let's suppose like this, if you see this one, pi and then direction and then rj, directed edge. This is directed edge from process to resource. So it means that P1, the Pi has requested an instance of resource type Rj. Okay, so this is called request edge, the process requesting resource. And arrow direction, if you see, this is very important, that direction of arrow. The direction of arrow is from process to resource. From process to resource. The second type of edge we have, that is called assignment edge. Mean directed edge from resource type Rj to process Pi. This is opposite of the request edge. If you see this one, Rj is assigned to Pi. This is the thing that, and this is called assignment edge. Mean the resource type Rj has been allocated to process Pi. Okay, so we have two type of edge. When we will make a resource allocation graph, one edge will be called request edge, other edge will called assignment edge. Okay, now how we will represent resources and process. Whenever we have process, then we will use a circle to represent the process, and to represent the resource we will use a rectangle. Okay, so to represent in resource allocation graph, to represent the process we will use circle, and to represent the resource we will use rectangle. And it's also possible that we have more than one instance of a resource, then we will use dot within the rectangle. To represent one instance, we will use one dot. So each instance as a dot within the rectangle. So we will solve in next second session of this lecture some examples, and you will see how we are going to make the resource allocation graph. So here the important thing that how we will represent process in resource allocation graph, we will use circle, and we will use rectangle for resource, and the dot we will put inside dot to represent the instance of that resource. Okay, so we will stop here. In next session we will solve some example, we will make some resource allocation graph, and we will check the deadlock occur or not. Okay, so before to finish, we will just take a quick overview what we discussed today. We start our discussion from deadlock, and we said deadlock is the situation that may exist in our system because we have several processes and they compete for finite number of resources. The number of resources are limited, and we have many processes that are working inside of our operating system. A process normally, the normal mode of operation is a process, if he need any resource he will request for resource, and if the resource is available it will be immediately given to that process, but if this is not available, that process must wait until that resource become free, and when he will get resource he will use that resource, and when he will finish his work then he must release the resource. Okay, so these are the three steps: request, use and release. Now we also discuss some examples from our life, that bridge crossing example, how the situation of deadlock occur here, and then we have seen if the two trains traveling towards each other on the same track, then maybe the chances that deadlock will occur in future. A person going down the ladder while another person climbing up the ladder, so this is also situation of deadlock. You cannot get the job without experience. You cannot get experience without job. So you cannot get job without experience. You cannot get experience without job. So this is also situation of deadlock. Now what are the necessary condition of deadlock? We discussed that we have mutual exclusion, hold and wait, no preemption and circular wait. Okay, so what is mutual exclusion? Because the resources, if the in our system the resources are non-shareable, then this situation can occur, mutual exclusion. Okay, so this is first reason of deadlock. Second, we have discussed that hold and wait. Currently a process holding at least one resource and waiting for another resource. So if this is the condition, then there are chances deadlock will occur. Then number third, we have seen the no preemption, that by force we are not able to take back any resource from any process. If we are using this technique, no preemption, then there are chances of deadlock. So to run our system smoothly, we need to include the method of preemptive approach. Okay, then number 4, at number 4 we discuss circular wait. In circular wait, the process they are waiting in a circle. Maybe P0 is waiting for resource which is currently held by P1, P1 is waiting for P2, P2 is waiting for P3 and so on. Pn minus 1 is waiting for Pn and Pn is waiting for P0. So we will continue in second session, and in second session of lecture week number 8 we will see that how we can make a resource allocation graph and how we can uh, check the deadlock occur and what are the reasons why the deadlock occur. So if you have any question, you can send me email or you can visit my office during my office hours. So see you in second session of lecture number 8.